Alrighty, you guys. So yesterday we talked about what a log is. We talked about how a log is like the inverse of an exponential. Okay, the log is an inverse of an exponential. And I'm actually going to turn to the page right before this for just a second so we can talk about that sort of format that we have for a log, how it relates to an exponential function for just a minute. Again, this was from yesterday. So if I have log base 2 of 8 equals 3, if I wanted to write that in exponential form instead, it would look like 2 cubed equals 8. I have this way that I can convert between log form and exponential form. So today, what we're going to talk about is how to evaluate a log. And this relates really closely to what we did with example 3 from last time. What's that value of A? What's that value for the exponent I would need to make this equation true? So on page, I think we're on page 13, that's what we're going to work on. That's going to be our focus for today, evaluating these logs, okay? As we're starting evaluating, for a lot of people, it is helpful to keep that exponential form in mind, especially when we get to things like the maybe second and third rows of evaluating. Remembering that this is tied to an exponential is really helpful. So as we look at A, log base 4 of 4. So what I am asking, right, this is equal to something. That's what we're trying to figure out. What I am asking is 4 to what power is equal to 4? Right? This 4 is here, and this 4 is here. And I want to know, what would that exponent have to be? So 4 to the what equals 4? 4 to the first, right? 4. So log base 4 of 4 equals 1. For B, same idea. And again, I am someone for whom writing out the exponential form is helpful. So 4 to what power gives me 64? 4 to the third power. So that means log base 4 of 64 equals 3. And then same thing for C. This would be 6 to what power equals 36? A second. For our next column, same, or row, I should say, same idea. So 2 to what power gives me 1/8. Very good. I want a negative exponent here because I went from a whole number to a fraction. That means I had to flip. I had to take a reciprocal here. And then 2 cubed would give me 8. It's the same idea, but those exponent rules that we've talked about are going to come into play here. For E, 5 to what power gives me 1/25? Right. Again, I've gone from a whole number to a fraction. That means we took a reciprocal. So this had to be negative, and then 5 squared gives me 25. Last one in this second row, 8 to what power gives me 1/64? -2 again. In our next column, we've got some more complicated arguments here for our logs, but we're going to set this up the same way. So this would be 9 to what power would give me the 5th root of 9? Very good. So we're using our exponent properties here again. If I don't like leaving this as a root, right, if it's more helpful to me to see this as 9 to the 1/5 power, so we can see that our exponents need to be equal, then that's okay too. This would still be 1/5. For 6, or for H, sorry, this would be 6 to what power gives me the cube root of 36. On this one, I'm going to go ahead and rewrite this. For G, you could probably see that without having to rewrite since it was a root of 9. But here, the number under my root is different. We don't have the same base here. So I'm going to go ahead and rewrite this. This would be 36 to the 1/3 power. And then 36 does not have the same base as 6, but I can rewrite it. And we saw this with a couple of our square root problems earlier in our unit last week. So this, if I wanted to change it to be a power of 6, would be 6 squared. So what I have over here is 6 squared, then to the 1/3 power, which I could use my exponent rules to simplify as 6 to the 2/3, power to a power I multiply. So then what does our log have to be equal to? 2/3, right? A lot of exponent rules came into play on that one, but it's all stuff that we've seen before. Questions on this one? This one was a little more kind of weedy and messy. Say that for me again. So the two things that I used here is I rewrote the root as a 1/3 power. Does that make sense? Okay. And then 36, I rewrote as 6 squared, so it would have that 6 that I was looking for. So it works because I could rewrite 36 as a power of 6. We're going to see something similar with I. Okay, I'll go through the next one a little slower. So I'm asking 2 to what power would give me the 4th root of 8? So I'm going to start by writing this as 8 to the 1/4 power. So I'm dealing with an exponent, which is what I'm looking for. That's what I'm trying to find for here. The problem still is though we don't have the same base, right? 2 to some power is not the same as 8 to some power. So I have to rewrite the 8 as a power of 2. So I don't want 8 to the 1/4. I want 2 to some power. So that 1/4 is going to stay, but what I need to figure out is what's the power that goes here. So 8 would be 2 to the 3rd power. Does that make sense? Same idea as what we did before with the 36, rewriting it so we have the same base. Now I can make an even comparison. So if I've got 2 to some power, that's equal to 2 to some power. Power to a power we multiply. So this would be 2 to the 3/4 power, which means that log base 2 of the 4th root of 8 is equal to 3/4. Problems like this are a reason why I like to rewrite it in that exponential format. This might be a little tough to work your way through without rewriting. And then our last line here. Again, I like to change these to that exponential form. 4 to what power equals 2? 4 to what power equals 2? What do I do to 4 to get 2? I took the square root, right? So the square root of 4 equals 2. What's the exponential equivalent of the square root? The 1/2 power. This would equal a half. So we saw a variation earlier where we went from like a whole number to a fraction, right? And we said that meant our exponent had to be negative, or whatever our log is equal to had to be negative, because we took a reciprocal, clearly. We're also looking at a variation now where I go from a big number to a small number, and that means that we're looking at some kind of root. For k, same idea. 49 to what power gives us 1/7. Oh, I got a couple of things going on here. First, I went from a whole number to a fraction. So what does that tell me? It had to be negative. Okay. The negative gets us to flip. So if this is to the negative something power, now I've got 1/49 to something. How do I get from 49 to 7? 1/2 power. And then our last one here, log base 16 of 2. So 16 to what power gives us 2? What did we say? 1/4, right? The 4th root of 16 gives us 2. Another way you could think about this, 2 to what power would give us 16? 2 to the 4th power. So this has to be a 1/4 to go the other way. One thing that we didn't see on here is we saw some starts with a whole number, ends with a fraction, but this would also work if I started with 1/2 and ended with 8. Okay. So 1/2 to the what power would give me 8. That's also going to be -3. Okay. I need to take a reciprocal to get from the fraction to the whole number. And then once it's flipped, I need to cube. Questions for me on evaluating without a calculator? Okay. Again, I personally find it helpful to look at that exponential format. Some people don't. If you don't find it helpful to have the exponential format written out, that's okay. Don't do that. I find it. The next thing I want to look at, just so that we can make sure we are all typing things in properly, is evaluating with your calculator. So if you would for me, please get out your TI Inspire. And we'll say some scientific calculators will have this as well. Check mine and see if I have it. However, I think mine do. However, scientific calculators often don't let you choose your own base. So that's kind of the tricky thing. There you go. So on your TI Inspire, let me pull mine up on my computer so you guys can see it up here too. It's like just to the left of the 1 key is where you can see. Here we go. I'm going to add a calculator here. And then it's, again, just to the left of the 1 key in blue, you can see ln and log. ln is something called the natural log. We'll talk more about that a little bit later. So you do, I think, see that on one of your problems there. The B, I think. But when you hit the log key, so I'm going to do Control to get my log. Your default is going to give you a space to put in the base for your log. On a scientific calculator, that is usually not the case. If I don't see a base for my log, I should say, that means that the base is 10. So for example, on A, we don't see a base. We don't see that subscript type there. That means that the base for my log is 10. And then we're taking the log base 10 of 7. We would need a calculator to do something like this because, like we talked about the other day, 10 to the what power gives us 7? I don't know, no integer, right? No rational number that I can think of. So that's why some of these we'll look at our calculator for. If you typed this in and you did not get 0.845, you may not have as many decimal places as me, and that's okay. But if you type this in and you got a wildly different number, then make sure you let me know so we can fix whatever that issue is. The next problem on your paper is natural log. You see ln. So we're going to do Control ln. You don't get to type in a base for the natural log because the base for a natural log is e. So this is a log base e. And again, we'll talk more about where e comes from later. But natural log is also a log. So if you see ln, that's a log. And then we're taking the natural log of 0.25 here. Again, you do this with me on your calculator.
Doesn't it matter if your calculator says it's in like the top right?
Nope, shouldn't matter if it's degrees or radians because we're not doing anything with angles. Okay. And then the last one, log base 3 of 128. Control log, type in your base, and then make sure you use the keypad to arrow out of the base before you type your argument. Again, if you got wildly different numbers here, make sure you let me know so we can take a look at what you're typing in. So most of what I'm going to ask you to do in this unit in particular, we can evaluate by hand. We can evaluate without our calculator, but I want you to know how to do it so that when we do run into some weirder stuff, like we couldn't do 3 to what power gives me 128. I don't know. And we can see clearly it's not going to be a nice value, right? So I just want you to know how to do it, how to type that in your calculator for when we need that. So on the next page, I'm going to put my calculator away. And we're going to go back to, I'm going to try to put my calculator away. There we go. And we're going to go back to some evaluating by hand here. So the last thing that we're going to look at is what kind of values can I use for an argument of a log? And we're going to do that by making some tables. So on example 3A, again, this little subscript number is called the base. This number here is called the argument. Okay? So when we're looking at log functions, the variable is typically going to be in the argument. Okay, that's what makes this a function or a log function. So here we've got log base 2 of x. That means we're looking at 2 to whatever our power is equals x. What we're used to being able to do for just about every function that we've looked at so far is pick any values you want for x, plug them in, see what you get. This gets a little bit trickier when we're talking about logs because whatever I choose for my argument, okay, whatever I pick to plug in for x is going to have a repercussion for my y. It's going to, whatever I pick for x is going to determine if I can actually figure out y on my own or if I'll need a calculator. And there are lots of options for things that we can plug in for x. There are also, as we'll see, some options for things that I cannot plug in for x. But let's take a look at our first log function here. And I want you to tell me some values that you think would be nice to have for x. 2 would be a great value to get out for x. What else might be a nice value to get for x?
4.
Why are you picking 2 and 4? Are you going to pick 8 next?
Yeah.
Why are you going to pick 8 next?
Because they're all like, so you're solving for like what the exponent is, they'll all be nice exponents.
These are all values that would give me a really pretty y, right? Okay. There are other values for x that I can pick that would give me pretty y's. What if I did a half? Would that be an okay y value? Sure. What if I did 1? Can I have a nice y value if I pick 1 for x? What would it be? Yeah, 0, right? So I'm picking values for x that are multiples of the base, right? I shouldn't say multiples, I should say powers of the base, okay? Or 1 is always a nice option. If I can get that like whole argument to be 1, that works out really well. So if I plug in 2 for x, right? If I plug in 2 for the argument, that means this guy would be 2 and my function output would be 1. If I plug in 4 here, my output would be 2. My log would be equal to 2. Log base 2 of 8 would be 3, since 2 to the 3rd power is 8. If I have a half here, 2 to what power gives me a half? 2 to the -1st would give me a half, right? Take the reciprocal. 2 to the what would give me 1? 2 to the 0s we talked about a minute ago. Okay. A 1/4 wouldn't be too bad. 1/8 would be okay as x values. For B, same idea. So here where our base for our log was 2, we picked x values that were powers of 2. For B, where our base is 3, what kind of numbers do you think we want to pick for x values? What? Powers of 3, right? So I might want to pick maybe 1/3. 1 will also work. 3, 9, 27. I could do 1/9 if I wanted to go sort of back the other way. So if I pick 1/3, this would be 3 to what power gives me 1/3. That's got to be -1. And my function value is -1. My input is 1/3. 3 to what power gives me 1? 0. 3 to what power gives me 3? The rest of these you guys can handle without, I think, too much stress. 3 to what power gives me 3? 1. 3 to what power gives me 9? 3 to what power gives me 27? 3. Okay. We often are used to picking -2, -1, 0, 1, 2, 3, easy, like close together integers for our inputs when I'm making a table for a function. I just want you to keep in mind, you could do that. I could use 2 here, but I would be asking 3 to what power gives me 2? That's not something I can evaluate without a calculator. I would have to have a calculator to do that, okay? But instead, I can choose values that are going to be a little bit easier. So good inputs for each function. 1 we used in both cases. We also looked at powers of the base. Both positive and negative powers of the base. Now here's the tricky thing. Are there inputs that we cannot use? Are there x values that are off limits here? What would be x values that would be off limits?
0.
Cannot have x be 0. Because if x were 0, if I stick with example B here, I'd be saying 3 to what power gives me 0? Well, it's not a positive number, right? Those are all going to give me bigger numbers than 3. It's not a negative number, right? Those are going to give me fractions. -1 gives me 1/3. -2 gives me 1/9. -3 gives me 1/27. So I get really teeny tiny numbers if I do negatives, but I don't get 0. If I plug in, the closest I can get is if I want it to be equal to 1 and my exponent is 0. But otherwise, there's nothing I can plug in here that's going to result in 0. So x cannot be 0. There's something else that x cannot be. Negative numbers. Why not negative numbers? Yeah, we're talking positive bases here. So whatever I plug in for my exponent is telling me take a root of +3 or multiply +3 by itself some number of times. If I'm multiplying +3 by itself a bunch of times, it's positive times positive times positive, however many times I want, okay, I'm going to get a positive number. So I cannot put in something for my argument that is negative because it's not possible to take a power of a positive number and get something negative. So all of our inputs here are going to need to be greater than 0. X has to be greater than 0. Okay. X has to be greater than 0. X cannot be 0. It also, let me flip this around. It also cannot be less than 0. Okay? It has to be greater than 0. Now here's the tricky part. For A and B, X has to be greater than 0. But for D and E, that may not be the case. That's not necessarily true. What I actually want to say is that my argument must be greater than 0. My argument must be greater than 0. For D, Could x be 0? Could I let x be 0 for d? I sure could. X could absolutely be 0 here. That would be 2 to what power gives me 0 plus 1, which is 1. That's okay. The problem is that the argument cannot be 0. So x could not be -1. That would make the argument 0. What else could x not be for d? The argument can't be 0 and it can't be negative. So x can't be -1. What else could x not be? Anything less than -1. So x cannot be -2, -3, -4.5. Our x values here have to be greater than -1. Anything bigger than -1. How about for e? What do I have to limit my input, my x values to for e? Yeah, my x values have to be greater than 0 here. Since we're multiplying, if it's 0, that makes the argument 0, which is not okay. If it's negative, that makes the argument negative, which is not okay. I would like you to try D and E. We talked about what kind of values you can use. I would like you to create a table now for D and for E. Did anyone pick -1/2? You did? So if I plug in -1/2 for x, what do I get for my function value? -1. Anybody pick 0? 0 for an input? If 0 is your input, what's your output? 0. Anybody pick 1? Let me get into the integers. I figured we'd have them. If 1's my input, what's my output? 1. Anybody pick 2? Good, I wouldn't pick 2 either. How about 3? We pick 3. If 3 is my input, what's my output? 2. What's the next number that you picked? 7. Yeah, right? Because 7 plus 1 is 8, which gives me a nice power of 2. So if my input is 7, what's my output? 3. How about for E then? The first value I picked was 1/3. Anybody pick 1/3? Couple of us? If I use 1/3 here, that means I would have 1/9. So 3 to what power gives me 1/9? That would be -2. Good. And then how about 1? Anybody pick 1? What do you get for your output then? -1. How about 3? I'm guessing was the next value for many of us. If I pick 3, what's my output? 0, right? 3 to what power gives us 1/3 times 3. 1/3 times 3 is a 1. So 3 to the 0 power gives us 1. Then 9. Is that what you picked next? 9. And then depending on where you started, maybe 27 was your next value, or maybe you were done with your table by then. If I use 9, this would be 3 to what power? Gives me 1/3 times 9. A third of 9 is 3. So this would be 3 to the first, gives me 3. And then if you use 27, 3 to what power gives me 1/3 times 27. A third of 27 is 9. So that would be 3 squared. Questions on these? Okay. And then last thing, little throwback, average rate of change. Find the average rate of change for h of x, that's this guy, over the interval from 0 to 3. 0 to 3. Find that average rate of change for me. Two-thirds? Okay. That is it for Unit 2. For the next couple of days, we'll be working on review, and then we're looking at our test on Friday. For homework tonight, you have an assignment up on Delta Math.